In this video, we're going to aim to complete the source code of the TicketMachine class that we started in a previous video. In that video, we looked at the creation of the outer wrapper of the class, the definition of its fields, the creation of a constructor that was then used to initialize the values of those fields. In the previous video, we then looked at the structure of methods, in particular methods like getters and setters. We looked at the characteristics of method headers and so on. So let's just review what we saw in that previous video. We saw that methods have a very regular structure. They have a header consisting of 4 elements, the visibility of the method, and that visibility means which other objects within a program are able to access the methods of this particular class. So if a method is defined as public, then objects of any other class within the program are able to call this method in order to ask an object to do something. They then have a return type. If that return type is void, then that means that this method will not be returning a data value to its caller. It will simply be carrying out some action. The third element is the name of the method, and we typically use camel case for naming our methods, but always start with a lowercase letter for the method name. And then we have some parameters, and we've seen that we can have varying numbers of parameters. We might choose to have no parameters to a method. We might have one parameter. In this particular example, I've illustrated that we can have 2 parameters. And in this case, the data types of the 2 parameters are different. So whatever calls this method will be expected to provide 2 values to be received by those particular parameters P1 and P2. The first value will be an integer, and the second value will be a string or a piece of text. And then inside the body of the method, there'll be some actions that are carried out, typically using the values that have been passed in to the call of that method. Now, one thing to note is that when a method has a void return type, and therefore is not returning a data value to its caller, then typically there won't be a return statement inside the body of the method. There are some exceptions to that rule, but as a general rule, we can say that a void method doesn't have return statements within it. Here's an example of a method that in fact does return a value, a data value to its caller. And I've chosen, just for the sake of variety, to indicate that this method will return a value of Boolean type. In other words, the return statement inside the body of the method is going to return a value that is either true or false. And so at the end of the method's body, I've indicated a return statement, and I've said we will be returning the value of a Boolean expression. Now that could literally be the value true or the value false. Alternatively, it could be any expression that gives a true-false result. So for instance, we might want to work out whether an integer parameter that's been passed into the method has a value that is greater than 0. Well, we can write an expression that compares the value of the parameter against the value 0, and if it's greater than 0, then the result of that expression will be true, and if it's less than or equal to 0, then the value of that expression will be false. So we could literally write return value greater than 0, and that will either return true or false depending upon how that expression evaluates on any particular call. This method takes no parameters, so the parentheses are empty. There's no particular link between the number of parameters a method takes and the return type. So void return type methods might take no parameters. Methods that return a Boolean return value might have 1, 2, 3, 4, any number of parameters. So there's no link between those 2 aspects. Now, when we're adding source code to the TicketMachine class, as we're planning to do shortly, there's no point reinventing the wheel. If we've seen something similar that does the job that we want, then we might as well imitate it. Remember, this is one of the aspects of learning. We observe, we imitate, we reflect, and we repeat. So we saw in the previous video that a standard getter method for a price field would look like this. The method's public, it's going to return an integer value because the price field is of integer type. Its method is getPrice, that clearly reflects that it's getting or returning the value of the price. It doesn't need any parameters, and then the body of the method simply returns price. And we could literally copy that code into the body of the TicketMachine class and now have a getter or an accessor method for our price field. Similarly, we've seen an insert money method. So this was used as an example of showing how a method could take a parameter, and that parameter's value could be used to mutate the value of one of the object's instance variables. So here, the insert money method is not going to return anything, it's simply going to carry out an action. It receives an integer value, which is the amount of money to be added to the balance, how much money the customer has inserted, and then the body of the method contains an arithmetic expression to calculate the sum of the current balance and the newly added amount, and stores the result of that arithmetic expression into the balance instance variable. So we will simply imitate those two pieces of code and write them into the body of the TicketMachine in due course. So here's where we got to in the creation of a TicketMachine class in the previous video. We've defined the outer wrapper, so the class header, the opening curly bracket, the closing curly bracket for the class. We defined two fields, one for balance, one for price. We defined a constructor where the constructor receives a value coming in to say how much are the tickets that are issued by this machine. And then the body of the constructor does what most constructors do, which is initialize the values of the fields. So we want the balance set to 0. No customer has inserted any money into the machine at the point the object is created, but we want the price of tickets to match the value of the parameter that was passed in here. So whatever value was passed in when the ticket machine was created now gets copied into the price field. So two of the things that we'll want inside the class are accessors or getter methods for the balance field and the price field. And we've already seen what a getter method looks like for a price field. So let's simply imitate the code that should by now be familiar to us. We start with the word public. The return type has to match the type of the field whose value we are returning. The name of the method uses camel case to match the name of the field, and we prefix that with get. And then getters typically don't require any parameters, so we leave the parentheses empty. And then we write the body. I like to write the pair of curly brackets straight away so the closing one doesn't get forgotten. Reposition the cursor, and then in a getter method the body simply consists of getPrice, and that matches or imitates the code we've seen in the previous video on the slides. So at this point it might be worth you pausing the video and thinking, okay, I've now got a getter for the price field. What would the getter for the balance field look like? And just follow the technique that I've encouraged you to use, which is to observe and to imitate, but making any necessary adaptations. So why not have a think about that, pause the video and give that a go. So we can make our lives a lot easier and save ourselves some typing if we follow the imitation idea to its fullest extent and say, well, I've already got a getter method for a similar field. Let's copy and paste that getter method elsewhere within the class, and then I'll be able to use that as the basis for defining the getter method for the balance field. Now in pasting, I've got an indication over here that there's a problem with the class. So let me just illustrate what the problem is. The error message is method getPrice is already defined in class TicketMachine. Well, that's fair enough because we've just copied and pasted literally a piece of code that was already there. I clearly don't want two getPrice methods that do exactly the same, but I was really only copying it because I now want to use it as the basis for a getBalance accessor method. So let's revise the name of the method and call it getBalance. We check that the return type matches the type of the balance field, which it does, so I don't need to make any change there, but I do need to change which variable is being returned, and instead of returning price, I want to return the value of balance. So let me compile now, and everything's okay, and it would be advisable to test to make sure that everything's okay. So let's create a ticket machine. Let's say the price of tickets is 1500 cents. Let's bring up the inspector to make sure that everything's initialized correctly. The price field is 1500. The balance is currently 0. Close the inspector and then call those two methods that I've just created. I'm calling getBalance, and that returns 0, which is what we would expect. And then I'm calling getPrice, which is returning 1500. Again, exactly what I would expect and hope it would return. Now let me just reinforce something I said in a previous video, that what we're seeing here on the screen is not the result of the getPrice method printing something. And yes, we have a visualization of that number, but this is an artificial way of representing the way in which a data value returned from a method is displayed to a human user. In practice, if the ticket machine were part of a larger program where many objects are interacting, then windows like this would not pop up on the screen as various methods are called and data values are being returned. This is simply for our benefit as humans because we are playing the role of another object interacting with the ticket machine object, and this simply tells us that when we call the getPrice method, the getPrice method returned us the value 1500, and now that's being shown to us. But this is not the same as the getPrice method printing out the value. I really want to stress the fact that returning and printing are two completely different things in the programming world. So let's add a further method. Let's add the insert money method, which again we saw on the slides. So we want public. This method does not return anything, so its return type is void. The method is called insert money, and now instead of those parentheses being empty, we want to receive an amount of money coming in, so a value representing how much the customer has just inserted into the machine. So we want an integer value, and we want to give that value a name so that we can refer to the value inside the body of the method. And then again, I'm going to add the pair of curly brackets, complete the body of the method, which says I want to change or update the value of the balance. So I want to make an assignment to the balance variable. So I quote the name of the variable I want to change on the left hand side. Then I use an assignment symbol. How do I want to change the value? Well, I want to perform a calculation. I want an arithmetic expression. And the calculation is to add the amount that's come in to the value that's currently in the balance and form that sum. And that sum is the value I want to overwrite in the balance. And I can express that in Java by saying balance plus amount. And then I write a semicolon on the end. So let's press compile. So that compiles okay. And let's see whether that works. Let's create a ticket machine. I'm going to reuse that value of 1500. I'm going to bring up the inspector because that's probably the easiest way of making sure that everything we're doing is working properly. And now I'm going to call the insert amount method and pass in, let's say, 500 cents. Click on OK, and balance has now been increased to 500. So in other words, we did a calculation whether the original value of balance was 0. We added 500 to give a result of 500, and we've stored the result into balance. Let's do that again. Let's insert some more money. Let's insert another 100. We can anticipate what the answer is going to be. We should expect, if we're inserting another 100, for the balance to go up to 600. So let's see whether that happens. Indeed, it does go up to 600. So again, let's reflect on that in the source code. So what happened is that amount now had the value 100, and this arithmetic expression took the original value of balance, which was 500, did a sum of 500 plus 100 to give a result of 600, and then that 600 value was stored back into the memory location known as balance, and that's how balance came now to have 600. So we've now got fields, balance and price. We've initialized those fields. We can insert money into the machine. We've got accessor methods for the price and the balance. So the remaining thing to do is to write a method to print the ticket. So you might remember that when we printed a ticket from the naive ticket machine, we had a fairly elaborate piece of output that said the Blue Jay line, it had lots of hashes, and it said the price of the ticket was however many cents it was. I'm going to start by doing something relatively simple in printing, just to introduce you to the idea of how we do printing in Java. So I want a method that I'm going to call print ticket. That method is not going to return anything. So this is the other side of returning and printing. This time, instead of returning something from the print ticket method, I do literally want to print something that a human user could then take away on a piece of paper, for instance. So as with all of the methods we've seen so far, I'm going to define my method as public. It's not going to return anything, so its return type is going to be void. I'm going to call a method print ticket. Once again, I use camel case, and then I have to think, do I need to pass anything into this method? Does it need to receive any parameters? And the answer is no, it doesn't, because by this stage, the customer has done all they need to do in order to get a ticket. They've inserted the correct amount, and now they're simply pressing a button, for instance, or the ticket machine recognizes they put enough money in. It's got all the information it needs, and the ticket is going to be printed. So we need no parameters. And I'm going to put the pair of curly brackets in. How do we print in Java? Well, the syntax is a little bit complicated, but you'll be writing this kind of thing over and over and over again. So you'll very, very quickly learn how to do this. And if you ever forget how to do it, then use observation and imitation. Go and look at a piece of source code that already does printing that you know about. Use copy-paste if that's appropriate, and make the appropriate adjustments. But essentially, the way that we print is we write a statement like this. System with a capital S, then a dot, then the word out, then a dot, and then the word print ln. Now, just be careful here, because that L looks a little bit like a 1. It's not a 1, it's a lowercase n. And it actually stands for print with a new line at the end. Now, what we're doing is we're calling the println method on the system.out object. So we're invoking a method here, and the println method is a little bit unusual compared to what we've seen so far, in that it can take some parameters or it can not take parameters. So there are actually different versions of the println method, some of which take parameters and one of which doesn't. So I'm going to start by asking the print ticket method to simply print a message like, here is your ticket. Here is your ticket. Now notice that any string we want to print out is enclosed between a pair of double quote marks. Now be careful, a double quote mark is a single character on the keyboard. It's not two single quotes. So be careful, make sure you find on the keyboard the character that's got double quotes on it. And now I need to make sure that I put a semicolon on the end of my statement. And now I can compile, create a ticket machine. Let's insert some money into the ticket machine. And then let's print a ticket. And you can see that printed in the terminal window is the phrase that we put into the system.out.println. Now again, just to reinforce that this is printing output for human consumption, this window looks quite different from the window you get when you call a method that returns something. So when you call a non-void method, that's what it looks like, which is representing the value that's been returned from the method. But this is what it looks like when we're literally printing from a method. This is human readable form. This is the form that's representing a value passed within the memory of the computer, if you like. So that's fine. Here is your ticket. We could make the printout more elaborate. Maybe we want to show that this is for the Blue Jay line, so we might say Blue Jay line. And I'll compile again. Over here, if I click on the terminal window, I have some options that allow me to clear what's in the terminal window. And so now when I call print ticket, we'll get something different. So Blue Jay line, here is your ticket. Now one thing you might have noticed is that I didn't insert any money into the ticket machine that time. I simply called print ticket, and indeed I can call print ticket as many times as I like, and it will simply keep on printing tickets. And hopefully in your investigations of the naive ticket machine project, you will have seen that the naive ticket machine exhibits exactly the same problem. There's nothing in the source code of our print ticket method that first checks to make sure that the balance matches the price of the tickets that we wish to issue. And we'll look at how to address that in a later series of videos. We won't worry about it for the time being. However, something to observe is that the price of the ticket has not been included on the output of the ticket. So it might be quite nice to show how much this ticket cost. We can do that quite simply by calling system.out.println, and instead of writing a string between the parentheses, we can pass the price of the tickets as a parameter. So this says call system.out.println and print out what's currently stored in the price field. So let's see the effect of that. Let's compile, clear the terminal window, create a ticket machine, and then call print ticket. Blue Jay line, here is your ticket, 1500. So you can see that print ln is printing the text and then moving the printing position down to the next line ready for whatever's printed next. Similarly, here is your ticket is printed and then the printing position is moved down to the next line, and then 1500 is printed and the printing position is moved down to the next line ready for anything else that might be printed. Now that's not terribly elegant. Perhaps we want to indicate, as well as the price, say the price of this ticket is 500 cents, for instance. Now there are a couple of ways that we could do that. We could write another form of system.out.print that doesn't have the ln on the end of its name. So this is a different method we're calling. We're calling the print method this time on the system.out object. So we'll say your ticket cost. And now let's see the effect of that. Compile. BlueJ line, here's your ticket cost, and then because we didn't use the println method, a new line wasn't added after the closing colon, so the number that's printed immediately after is right up against the end of the text that was output. Now notice that Java does not add any spaces automatically. If you want there to be a space between the colon and the thing following, you have to include it explicitly in the string to be output. So let's look at the effect of doing that. So now you can see there's the explicit space immediately after the colon and before the 1500 is printed. So that's one way that we could do this. There's another way that we can do this, and that is to use what's called string concatenation. We've seen that Java uses the plus operator, or the plus symbol, for arithmetic addition. So if we have two numbers surrounded by a plus symbol, then Java calculates the sum of those two numbers. Java reuses this plus symbol for an operation called string concatenation. So if we have a string and a plus symbol, Java interprets the plus symbol quite differently. It clearly doesn't make sense to add a numerical value to a string. And so what Java does is it turns the numerical value into a string and then uses the plus symbol as a concatenation operator. In other words, it's going to join those two strings together when they appear in the output. So instead of writing two separate system.out.print and println statements, we can write a single println where we want concatenated this string with the numerical value turned into a string. Let's see the effect of that. I'll clear the terminal window. And there it is. So what we see now is how to add some basic methods to the source code of our TicketMachine class. And although this is not the complete TicketMachine class as you will have experienced in the naive TicketMachine, we've covered enough of the basics of how to write these methods that you could go away and complete the source code to be like the naive TicketMachine's version. So for instance, the naive TicketMachine version has a third field called total, which would also need initializing inside the constructor. If you wish, you could define an accessor method for the total, just like we've done for the price and the balance. When we print the ticket, one of the things we need to do is deduct the price of the ticket from the balance. Now we haven't introduced the subtraction operator, but you should be able to infer from the way that addition works in modifying a variable that subtraction is going to work in a very similar way. So it should be possible for you to add some additional code to your version of the print ticket method that then subtracts the price of the ticket from the balance as part of the printing process. And another step to take that you'll find in the naive TicketMachine is that when we're subtracting the price from the balance, we want to be adding that amount into the total money that's been received by the TicketMachine. So that's the purpose of the total field that we don't have here, but is in the naive TicketMachine class. We then add and accumulate the price of tickets that have been sold throughout the course of the object's life. So why not have a go as your own exercise at completing your version of the ticket machine to look more or less the same as or very similar to the version of the ticket machine in the naive ticket machine project. And maybe try that without actually going and looking at the source code of the ticket machine class. Do as much as you can and then maybe refer to that if you get a little bit stuck. But you'll learn a lot from just the basic process of typing methods in, finding errors, correcting them, making comparisons with what you've seen before, and you'll gain confidence in writing source code by doing that.